Okay, in this video, we're going to cover section 11.2 about dependent samples. Here's a hint for you guys. How can you tell if samples are dependent? When you see a table with 3 rows, with the first row has the name of the variables, and then one row has the data from an action before, and then the second one have data from an action after, then you can be sure that this is about dependent samples. The way we test the hypothesis for dependent samples is very different from independent samples. So let's read this question. The IRS gets frequent complaints that their tax auditors are rude and that they harass citizens whose returns are being audited. To try to improve public relations, the government conducted a one-day sensitivity training seminars to the auditors. A random sample of 10 auditors who participated in the seminar was selected. The data below show that the number of complaints for each auditor in the sample for the month prior to the sensitivity training, and then how many complaints they got after they received the training. Auditor number 1, for example, had 5 complaints before he gets the training, and then after he got the training, he received 3 complaints, and so on and so forth. Test the claim that the average number of complaints during the period after the sensitivity training has decreased, is less than the average number of complaints before the training. Use a 5% level of significance. How do you work with dependent samples? The first thing, guys, that you have to do the difference of before minus after. So it's before minus after. And you need to test the difference. So if you do 5 minus 3, you get 2, 7 minus 8, you get -1, and so on and so forth. So you have to do the difference. And let me show you how you're going to set up the null in the alternative hypothesis. You're going to test that the mean, the average of the difference, whether it is greater than 0, less than 0, or not equal to 0. This is how you can tell, how you can figure out, just how to set up the alternative hypothesis. For example, if an auditor received 8 complaints before the training, and if the training is working, you would expect that this person will receive less complaints after he does the training. So let's say the month after he received 5. Ask yourself, what's 8 minus 5? You're going to answer it is 3. Then ask yourself, is 3 positive or negative? You're going to say positive, greater than 0. Then this will be your claim. The mean of the difference greater than 0. HO is always a statement of equality, so mean of the difference equal to 0. And then you put this data on the calculator in L1, and you run a t-test, one sample t-test. I already put the data in L1, so I'm just going to bring the calculator up and show you stat. And if I press enter, then you can see my data is in L1. Then I'm going to go to stat, tests, t-test, enter, data, mu0 is 0. It's always 0 when you work with dependent samples. My data is in L1. Don't touch the frequency, and you want to test the mean of the difference is greater than 0. So choose greater than and hit calculate, draw, and look, guys. This is the test statistic is 0.802 to 3 decimal places, and look at the p-value 0.2217. So this is the p-value. Let me just scroll down. 802, p-value is 0.2217, which is bigger than alpha. You fail to reject the null hypothesis. And then the good conclusion will be, if you fail to reject HO, you start with there is not enough evidence at the 5% level of significance to support the claim that the number of complaints have decreased as a result of the training. Now, if you guys want to use StatCrunch, no problem. Let's show you how to use StatCrunch. I put the data already in one of the variables, and you go to stat, t-stat, one sample with data. That's the data you selected, and we're testing against 0, guys. And then you need the mu of difference greater than 0. And if you want to show the p-value plot, you can do it. Hit compute and watch. Look, 802, 02217 for the p-value greater than alpha. You fail to reject HO, and look at the p-value in action. It's right here. So this is how you work with dependent samples. This is the end of the video.